Hello maths fans, welcome to part 2 of the 50k subscriber Q&A celebration, where I will be trying my very best to get through the remaining questions from the original live stream which went out last month. So the response was overwhelming, to say the least. There were 258 questions submitted. I got through 108 in the actual live stream, which was almost 100 minutes. So I was doing pretty much one question per minute on average. And what I'm going to try and do here is go through the remaining 150 questions, hopefully a little bit faster. Now that I've said that, this could well be a 2.5 hour video. We'll see. So I'm just going to post this pretty much unedited, just like the live stream. So hopefully you still get the same experience, but I didn't want all of you who sent in questions to feel like you missed out. Just as with the live stream, I have the questions in front of me on the Google Doc, thanks to those of you who submitted questions. I haven't looked at any of them, so if there's any surprises in there, you will see my actual reaction to whatever questions you've thrown at me, and I'll try and get through as many of them as I can until either I get bored, you get bored, my camera maybe runs out of memory. I mean, who knows at this point? There's 150 theoretically still there, so we'll see how far we can get. Okay, first one is from Quaisido. Hello Quaisido, thanks for your question, which says Generation 1 starter Pokemon and favourite other maths personality or YouTuber. It's a pretty nice variety of questions there. So Generation 1 starters, so you've got Bulbasaur, Charmander or Squirtle. If I'm playing the game, I pick Bulbasaur because he's so strong on the early gym bosses that, you know, it's kind of, otherwise it's really hard to start with. But in terms of like most badass, obviously Charmander, because Charizard is pretty much unstoppable. So it's a toss-up for me. If I'm trying to just complete the game, Bulbasaur, actual favourite, Charmander. And then favourite other maths personality or YouTuber, to be honest, it's hard for me to look past Matt Parker. His videos are great. He's a lovely person. I was actually playing croquet with him last week, which was a whole thing. Maybe I'll tell you that story in another video. But Matt's great. He's just as funny in real life as he is in his videos. And he's done such a great job of really popularizing maths online. So, Matt Parker. Right, next question. Jaden. Hello, Jaden. Jaden has asked, how tall am I? I am 6 foot tall, Jaden. Pretty much bang on 6 foot. So is that 180 centimeters? Maybe? I don't know my conversions. Right, next one. Isaac has asked, what is the course that my students struggle the most with? Good question, Isaac. In terms of my first years, they tend to find, we do a course in the second half of the year that I teach called Groups and Group Actions. And it starts off, it's hard, it's all hard, but it starts off introducing the axioms for a group, which is reasonably okay. And then we progress onto quite complicated abstract algebra topics. So we're talking about isomorphism theorems, we look at the automorphic groups, quotient groups, normal subgroups. There's a lot of stuff that comes in there where a lot of my first year students tend to get a little bit stuck, but it's hard. It's definitely, I think, the hardest first year course that we do at Oxford, and I'd say it's probably the one that they seem to struggle with the most. But good question, Isaac, thank you. Okay, it's going well so far. Yusuf has asked, what career paths would be possible for a maths major beyond academia? Good question, Yusuf, thank you. Pretty much anything. So I think maths is one of those subjects where there's no obvious career. It's not like doing law or medicine where you become a lawyer or a doctor. So what maths does teach you is problem solving, creative thinking. Also, it kind of teaches you to be able to apply the skills that you learn in unfamiliar contexts. And all of these are very transferable skills. So maths is actually one of, if not the, most sought after degree for the majority of top employers. Like if you could sit down some of the top employers around the world and ask them, like, you know, what kind of degrees do you want your potential future employees to have taken, maths would appear very high, if not at the top of that list. So you really can go into anything with a maths degree. I guess the most common ones that people think of would be anything to do with finance, because you're working with numbers and you're dealing with numbers, so you learn that obviously doing a maths degree, but you really can do absolutely anything. Okay, Akagami has asked, is practice the main solution? I'm assuming this is a question of how to be better at maths, and pretty much yes. I talked about this in my video with Mike Boyd, when I taught him how to pass the Oxford Maths entrance exam. And as you saw there, I taught him for a couple of days, and he went from a 20-something to 60-something, purely from just practice. Of course, he had the advantage of having done an engineering degree, but the point we were trying to get across in that video, and it was amazing that it worked so well, it could have gone wrong, but it worked an absolute treat, was we were emphasizing that maths is a skill just like any other skill that you can think of, and so therefore you have to practice to improve. And yeah, there's no shortcuts, to be honest. Maths is certainly easier for some people. If your brain works in a certain way, maths certainly makes more sense to some people than others. But if you want to get better and improve, I would say practice, practice, practice. It's hugely important. Because you get used to the types of questions, you get used to the techniques, you begin to see how to apply things, you just generally become more numerate the more you solve maths problems. All right, Pra has asked, would Isaac Newton be able to pass a 2021 A-level? Interesting question, Pra. I can only hypothesize, because obviously I do not know the answer to this question. I don't think anybody knows the answer. I guess in the sense of a lot of A-level is based around calculus and geometry and algebra, and these were things that existed in Newton's time, then quite possibly. So in terms of the topics, most of the stuff you're studying at school up to A-levels, most of it was around when Isaac Newton was around. It's only once you sort of get to quite high level university, third, fourth year, when you start to study much more modern phenomena in maths. So in that sense, he would probably know the techniques to be able to solve the questions, but he would probably not recognize the notation. So the notation has changed quite a bit. And of course, there was this whole thing between the notation of Newton and the notation of Leibniz. So I think Newton would know the techniques, but would probably not actually be able to understand what the question was asking in the first place. So who knows, to be honest, but a great question, good one to think about. Okay, Robert has asked, this is a good one. How long does it take to do your hair, and do I have a personal hair stylist? So I do not have a personal hairstylist. I've been doing my own hair all my life. I started sort of this ridiculous, whatever you call this style, I guess emo kid. I started styling my hair when I was a teenager, and I've done it ever since. So I think I had a lot of practice. How long does it take to do? Anything from like 1 to 5 minutes. Some days it's like I get like texturizing clay, rub it in my hands, in the hair, and then it's done. Today was one of those days. This was pretty quick. This was like 1 minute. But other days it sort of doesn't behave. You know, if I've slept on it funny or various other things, then it doesn't do what I want it to do, and it takes a bit more kind of sculpting. But yeah, just a couple of minutes, to be honest, because it's going for like the messy look. It's not too tricky to just ruffle it up a bit and go with it. Good question, Robert. Joe, have you had any weird or wacky things happen in an interview? That's a good one, Joe. The main thing that comes to mind here, I'm not sure if this is weird or wacky, but I do remember doing a podcast interview a couple of months ago, and my oven timer went off, and I was like, oh, it's fine, the thing won't burn. And then it did, and then my smoke alarm went off. So I had to because we were doing the podcast over Zoom, so whilst the whole thing was happening, I think the presenter sort of said, wait, Tom, is there smoke behind you? And then the smoke alarm went off, and I think it was cooking a pizza, was very burnt, and it ruined my dinner. So I don't know if that's weird or wacky, but it's certainly something that comes to mind. I managed to burn my dinner and set my smoke alarm off during our podcast interview. As for other things, we were recently filming some new number file videos, so they'll be out soon. And in my garden there are some ducks, and during the interview the ducks came and started tapping on the door So we kind of interrupted filming, and Brady went over and started filming these ducks that were trying to get in through my back door because clearly they wanted feeding. So that was quite entertaining. I guess that's probably the only other one that immediately comes to mind. We've got me burning my pizza, setting off the smoke alarm, and the ducks trying to invade and take the spotlight away from the latest batch of number file videos that we were doing. Good question, Joe. Thank you. Zaki has asked, what topic do you think students at GCSE and A-level are generally weak at? Do you think A-levels prepare you well enough for degree when there is so little analysis and proof type of work? I honestly don't know what students would be weakest at because I do not teach A-levels, right? I'm aware of roughly what's on the syllabus, having done obviously a couple of exams myself recently, and obviously teaching first year students, I kind of know the level they come in at. And I think you do make a good point, Zaki, about there's not that much proof. So you do some proof at A-level, like you might do some proof by induction, some proof by contradiction perhaps, but you're right in the sense that once you go to university and you get analysis thrown at you and this kind of idea of epsilons and deltas, and it's a whole new thing. And that's something that a lot of first year students find really, really difficult. The only reason I didn't say that was the hardest one I teach is because I don't teach real analysis. I teach complex analysis to my second years. So yeah, I think I see your point in that it doesn't necessarily prepare you for this crazy world of real analysis, but at the same time, I think because a lot of people doing GCSE and A-levels don't necessarily want to be mathematicians, like throwing these epsilons and deltas and things at people, I think would just be too abstract for like a high school level. So there's certainly like a little bit of a gap there for sure, and I think that's something that is, if you're about to start studying maths at university, you want to look up like methods of proof and begin to try and get, there's a really good book by Martin Liebeck that I remember reading called A Concise Introduction to Pure Mathematics, which kind of bridges that gap between high school and university really nicely and introduces you to the concepts of proofs and epsilons and deltas and stuff. So yeah, I mean, it could be a bit better perhaps, but as for could we change it, I'd say probably not. It's needed for students who want to study maths at university, but there's so many students that do maths A-level that don't go on to do maths that I think it would actually put so many people off if you talked about that too early on, for example, at school. But good question. Stephen wants to know, what's 10 times Q? I have no idea, Stephen. It's 10Q. I mean, not really sure I can say much more than that. Okay, Thomas has said, would you say going back to uni to do BSc in maths at 30 plus is too late to get into research or PhD after? I would say it is not. I don't think age has anything to do with your ability to do anything, to be honest. My PhD supervisor turned 70 when I was working with him during my PhD, and he's as sharp as ever. You know, he was, every meeting we had, he would tell me incredible ideas, have these incredible insights. So I don't think, as long as you stay mentally active, I don't think age is in any way going to affect you. The only thing that might be tricky going back to do a degree sort of in your 30s is you've probably forgotten a lot of what you did at school. So you might find it quite hard, or you might need to refresh the school stuff because you sort of need to sharpen up those skills, sharpen up your mental arithmetic, your algebra calculation skills and tools and techniques. But once if you manage to do that, then I don't think it makes any difference at all. So go for it, I say, Thomas. Okay, Ross has asked, do you ever get mature students doing maths at Oxford? I personally haven't taught a mature student, but I know that they exist. I do remember mentoring a guy a few years ago who was older. He was a refugee. And I'm pretty sure he definitely got a place at university to do maths. I'm not sure if it was Oxford, but I was helping him with his UCAS application. So mature students certainly exist, definitely. There are mature student colleges in Oxford as well, specifically for older students who come in to do degrees. So yeah, again, I personally haven't taught one, but I'm sure they exist. Okay, Xander, why did I choose Oxford? So when I was applying to university, as a high school student, just doing my A-levels. The idea was put in my head from my teachers after my GCSE results. They sort of said, have you thought about Oxford and Cambridge? And so I went to an open day, drove down with my parents. We went to Oxford one weekend and then went to Cambridge a few weeks later, just to get a feel for like the places. And obviously we went to some talks, learnt more about the university admissions process, that kind of thing. But the main thing for me was, once the idea was in my head that I potentially could go to Oxford or Cambridge, I was like, right, I'm going to aim as high as possible. I want to do this. And then I just felt that Oxford to me seemed more like home, in the sense of it felt more like somewhere I'd be more comfortable living and working and whatnot. But obviously I then went to Cambridge, so I clearly enjoyed being in Cambridge too. But now that I'm back in Oxford, I guess I can say, I think Oxford, to me, Cambridge is prettier, and there's more green space, and it's more like a market town. But Oxford is a bit more like a city, which I prefer. So it feels a bit busier. There's a lot more happening outside of the university. Cambridge to me felt very like centered on the university, whereas Oxford, there's lots of other things happening. So I think that's what sort of drew me back to Oxford. But originally as a student, when as I said, I literally went to both to visit, and Oxford just felt more like me when I was 17, 18. Okay, Wiek, W-I-E-K, Wiek. I apologize if I'm butchering your name. I'm trying. Do you have any suggestions for textbooks for learning mathematics for physics? Ooh, and probably the one I mentioned in the first live stream. So what was it called? Advanced Engineering Mathematics by Krasig, or Mathematical Techniques by Jordan and Smith. They're both such good textbooks for sort of any kind of like applied maths that you're going to use in physics, engineering, etc. They'd be my go-tos. Outside of that, I'm not entirely sure, to be honest. Beyond specific things, like if you want quantum this, or if you want relativity this. But yeah, I think in general, I really like both of those books, Advanced Engineering Mathematics and Mathematical Techniques. Okay, Anna has said, can I please start an A-level math series? It would be really helpful. Okay, Anna, noted. It's not really a question, but I'll add it to my, my list of possible ideas. Thank you. Okay, Basuardo. Apart from different entrance exams, what are the main differences of doing maths at Oxford versus Cambridge for undergrad? So obviously I only did my undergrad in Oxford, and then my PhD was Cambridge. But I did teach some of the undergrads when I was a PhD student in Cambridge. The courses, I think it was just a slightly different course structure. So I remember teaching in Cambridge, I taught first year vectors and matrices was a course. I taught, which is slightly different, because in Oxford we teach you linear algebra, it's where you cover matrices, and then we do vector calculus, where you cover, or multivariable calculus, where you cover vector calculus. So doing vectors and matrices in Cambridge kind of touched on bits from both of those. And then I also taught a dynamical systems course in Cambridge, which is a third year course, which is similar to the nonlinear systems course in Oxford, which is a third year course. I taught some math biology in Cambridge, which felt very similar to the math biology I've done in Oxford and now teach in Oxford. So I think in general, lots of the courses are the same. They're taught in a slightly different order perhaps, but the main differences happen towards the end. You're like fourth year. So in Oxford, you do your fourth year, it's called Part C. In Cambridge, your fourth year is called Part 3. Play the same role. So in Cambridge, Part 3 has a lot of physics courses in there within the maths department. You get like astrophysics and fluids, or something like that. I remember going to the lectures, it was really cool. And biological fluids as well. So there's kind of more specialised things that you can do in Cambridge versus in Oxford. Similarly specialised topics, but different. So that's the main thing. I think the first at least 2, if not 3 years, felt to me or looked to me very similar. And then obviously in the fourth year, there was more specialised fluids courses in Cambridge, because Cambridge is massive in fluids and theoretical physics. And then in Oxford, there's like a lot more you can specialise in, like math bio and other kind of different courses. So it very much depends on the researchers and the groups that are present at each university. But I imagine that's the same across most universities. The core stuff's kind of the same, and once you get to like the more advanced third year, fourth year courses, it's going to be determined by the research that's happening in that university. Good question, Basuado. Etienne has again asked, how long does my hairstyle take? Between 1 to 5 minutes, Etienne. Had that one. Ben, any advice before you start your A-level maths and further maths next year? Again, lots of practice, to be honest, Ben. So even if you're set, you're going to learn a new topic, a new technique in class, and then you're going to be set certain questions, I assume, for homework, I'd recommend just doing as many of them as you can. So even if, maybe you're told to do all of the odd numbered questions, I'd recommend doing all of the questions, for example, because again, the more you use these techniques, the more familiar you get, the better you get, and it's practice, practice, practice makes you a lot better. So that'd be my main advice, to be honest, would be just to try and do as much practice as you can. And if you don't understand something in your lesson, so the way your teacher has taught it, hasn't worked for you, then go and try and find, let's say, a YouTube video or even a textbook where it's explained differently. Because often, if you explain something from a different perspective, that one might make more sense to you. And so it's not that you don't, it's not that the topic's impossible for you, it's just explained in one way, you're like, what's going on? And then someone else explains it differently, and it makes complete sense. So that's a really important thing to sort of keep in mind. If there's something you're struggling with, look for other people explaining it, and I'm sure you'll be able to find somebody who explains it in a way that makes sense to you. Question 126 from X Not In X, great name, who has asked, black or whiteboard? Blackboard, clearly, it's behind me. Blackboard's all day. Maths just feels better on a blackboard. Kevin, what subject would you have studied at university if it wasn't maths? Ooh. Answering that now, probably physics, because I have interest in quantum theory, relativity, fluids, all topics you study in physics as well. But if you'd asked me during my A-levels, maybe geography? Because I could have only done geography or chemistry based on my other A-levels, and I loved geography. So as I mentioned in part 1, I actually got a higher mark in my geography A-level than I did in my maths A-level. So maybe geography, to be honest. But now I think physics, based on my interest. I think I'd love, and still would love, to do a degree in physics. I think that'd be really cool. Question from someone, what is your favourite number? My favourite number, there are a couple, is E, because obviously it's tattooed around my arm, first 120 digits. And also the number that appears in my PhD thesis. I've talked about this one before in my number file video about where does river water go. And I've now forgotten what that number is. I think it's 3 divided by 2, where 2 is to the power of 9/4. It's some crazy, ridiculous number involving 2 to the power of 9/4 or something. I love that number because it appeared in my research. So that one, or E, if I'm being a bit more traditional. Okay, Captain Vion would like to know, what is my favourite equation? It's got to be Navier-Stokes, hasn't it? I mean, when you've got it tattooed on your... I am Navier-Stokes guy, fluids guy. It's got to be Navier-Stokes. And how to choose a perfect topic for research? Good question. That's a tough one. So for me, it was something that piqued my interest, to be honest. So when I was looking for PhD projects, I looked online. I found the fluids group in Cambridge. I sort of did some research and found out it was a really good place to do fluids, and saw suggested projects from the lab group. So I thought doing experiments sounded really fun, something I'd never done before, didn't think you could do with maths, and so that kind of excited me. And then I looked through the suggested projects, and there was one talking about river water and oceans and rotating turntables and experiments, and it just sounded amazing. Just sounded like a really cool problem that immediately got me excited. So, I was kind of guided by my supervisor because he'd suggested this as the original question, but then I kind of took it on myself and, once I started digging deeper, figured out exactly what I was going to look into for my actual PhD project. So I would say sort of be guided by experts in the field because they will know what are the rich research problems. So I think that's a good starting point, but then also make sure you find something that you're excited about. So I like to think that maybe the reason I was drawn to looking at this environmental problem was perhaps because of my interest in geography. The fact I did geography A-level and really enjoyed it perhaps sort of led me to this environmental fluid dynamics sort of area that I went into. But yeah, you've got to be excited about it because you're going to spend a very long time studying that question. Rory, am I interested in cryptography and cryptocurrencies? I mean, cryptography, I certainly enjoy the maths in cryptography, for sure. There's lots of neat stuff on my website about RSA encryption from one of my student interns, Georgie, wrote a really nice series on that, and that was really cool. I learned a lot from Georgie reading that. Cryptocurrencies, I mean, I'm aware of them. I don't personally invest. It seems very volatile to me, but you know, it seems almost to me like gambling, is what I would say. And I don't gamble. So I guess I know the maths behind gambling and that you're going to lose or you're expected to lose. So beyond sort of knowing what they are, I wouldn't say I'm interested. Afonso, love from Brazil. Hello, Brazil. Do I have any fellow mathematicians in Brazil? I've got a couple of people I've chatted to online, on Instagram and stuff from Brazil or Twitter who are mathematicians in Brazil, but no collaborators yet. But it's amazing, honestly amazing that people in Brazil watch my videos. So thank you so much, Afonso. It's so cool. I love this. Karen, most fascinating equation. Fascinating equation. That's a good one. I guess, so I really like, Euler's identity, right? The one I've got tattooed on my chest, and the e to the I pi plus 1 equals 0. Now, if you take that in its actual form, e to the I theta equals cos theta plus I sine theta, then you can plug in any value of theta. So you plug in theta's pi, and that gives you Euler's identity. Now, I really like the full version of Euler's formula because you can literally plug in any value of theta and get a relationship between e to something equals real part plus imaginary part. And to me, that's fascinating. So Euler's identity is awesome because it looks so nice, but like the actual Euler's formula where it comes from, I think is actually fascinating because you can create your own identities from it by just plugging in your favorite value of theta. And I recommend you should all do this. Okay, Ashwin, more clouds to 3B1 Brown. Yes, please. Grant, if you're watching, you came to Oxford last time. Maybe I should come to Cali. We can film some stuff in California. Obviously, once the pandemic, hopefully, is over. But yeah, that'd be super fun. Vlatka, do I like strawberries? I love strawberries, Vlatka. We actually had a post-exam celebration event with all of my math students a couple of weeks ago. It's a tradition on the last day when all of the students at St Edmund Hall, at Teddy Hall here in Oxford, when they finish their exams, we all have strawberries and cream and drink champagne in the college graveyard. Don't know why it's a tradition, but it is. And it was awesome. And we all loved it. And it was a really sunny day. And it was just the nicest sort of relief of everybody from having finished their exams. So yes, definitely a strawberry fan. Sebastian, do I know some uni in the Czech Republic or unis outside UK, USA? I don't know any off the top of my head from the Czech Republic, to be honest. I definitely know some outside of the UK. I recently went to Bielefeld University, actually in October 2019. So I say recent, I mean, as recent as you can kind of get, given the lack of travel for the last sort of year and a half. And that was awesome. They invited me to come give a talk, which was really good fun. I did a couple of talks, did one for all of the lecturers about how to make maths engaging, and then did one for all the students looking at penalty kicks and maths and sport. So that was really good fun. But yeah, I'm afraid I don't know any in Czech Republic, Sebastian. You'll have to let me know. Ria has said, she's really blind. What do I look like? I mean, at the moment, I've got ridiculously white/blonde hair. I have my lip pierced. I have 2 big spikes in my ears. How else would I describe myself? Blue eyes. Don't know, I like to smile a lot. That'll have to do. Terrible description, but that's all I got. Adam has said, why don't we understand the distribution of the primes? In short, because it's super irregular, is what I would say about that, Adam, to be honest. There's just no obvious pattern. And you can kind of see this for yourself, I think, if you're sort of new to this thing about the prime numbers. If you, let's say, take the first 100 numbers and like list them in a grid or a table and then try and circle all the primes, just as you think you found a pattern, you will be able to find somewhere where it fails. right? So, you know, you might be like, oh, every like third number that ends in a 3 is a prime or something. Eventually you'll find a counterexample. And that's kind of what we mean by why we don't understand it, that any kind of pattern you think you have just doesn't, like, it will eventually fail, unfortunately. So I think that perhaps encapsulates why we don't understand the distribution. There's a really nice article that I put up on my website this week from Lola, which actually was an entry in the Teddy Rocks Maths essay competition. And she wrote a lovely description of what we do know and don't know about the distribution of the primes. So I really recommend you check that out, and maybe that'll fill it in a lot better than I just did. Right, Ian, my football team, and have I ever thought I might be able to keep myself in math academics, and any advice on knowing yourself when to quit maths? Okay, my football team, Man United. So I had a season ticket for about 10 years when I was growing up. I used to go every weekend with my dad because we lived quite close to Manchester. So that was awesome. They're still my team. And then when you're saying about academia, I guess whilst I obviously work at the university, I guess I don't have a traditional position because I no longer do research. So in that sense, I find it quite, I don't know whether I could say I am or I'm not in academia. I'm definitely teaching undergraduates, and obviously I'm part of the university and part of St Edmund Hall. But a lot of my job is doing things like this, right? I'm doing my YouTube channel, Tom Rocks Maths, talks in schools, talks at events. So I guess I did spend a year outside of university. So I worked for the BBC for a year doing a science radio show. And I did miss just doing maths, to be honest. That's kind of one of the reasons why I came back. And also because I wanted to do like YouTube stuff and explain maths and share my passion of maths with all of you. So I don't know. I've been quite fortunate. I've been able to get this position. And obviously, huge thanks to Teddy Hall for supporting me with this. Knowing when to quit, I guess when you don't enjoy it, to be honest, right? Like, so a PhD, you will reach a point in your PhD, I certainly did, 3rd year, 4th year, where you're kind of like, I have spent so long studying this same problem. And you maybe lose a little bit of that joy, to be honest. I just think that's part of doing a PhD. It's, unfortunately, you kind of have to go through that. Not sure I know anyone who hasn't had some of those days where they're like, do I really have to keep doing the same thing? But if you push through it, then you begin, I think, hopefully, to sort of, fall back in love with what you do. At least I absolutely love what I do, and I love maths, and I love my subject and everything about my job. So I think, as with anything, if you no longer love what you're doing, then maybe that's the time to quit. All right. Antonio, what was it like collaborating with 3 Blue 1 Brown? Awesome. Grant's lovely. We met at a conference. Obviously, we have lots in common. He actually studied in Oxford for a term when he was at Stanford. He did a year abroad in Oxford, a term abroad, semester abroad in Oxford. So we were chatting about that, and then I said, totally come visit me. And then, we set it all up, and he came to visit, and we made some videos, and it was great. Really, really nice guy, really, really lovely chap, and obviously very good at maths. So yeah, we had a lot of fun with that. Iqbal, how to tackle maths problems which you've never gone through in your life? Is it possible to tackle any unknown problem without having knowledge of a certain field? Okay. So if you come across a maths problem that you don't initially understand, so the advice I give to my students is make sure you understand what the question means. So what I mean by that is, if you've got words that you don't really recognize, or definitions that you're like, I don't know what homeomorphic means. Like, a good starting point is to look up and write out what are the definitions of the things mentioned in the problem. So that would be my advice if you come across a difficult problem. Whether you're going to be able to attack it without that knowledge, I mean, probably not, right? If you're asked to show 2 things are homeomorphic and you don't know what it means to be homeomorphic, you've kind of got no chance. But yeah, my main advice, same advice I give to my students, if you don't understand what a question's asking, you've got to look at what those words mean. Start by writing out your definitions, and a lot of the time, that will point you in the direction you need to go to be able to solve the problem. Okay, Beak has asked, do you have any theorem or corollary named after you? Because James Grime in number file has the Grime corollary. I don't believe I do, though I have this result, which I have tattooed on my arm here. So this is a result relating to the vorticity of a river outflow into the ocean. And I added in this term, this time-dependent term, it was, according to my examiner, the main result of my thesis. So I don't know if it's named after me, but if anybody goes on to use that, which hopefully they will, then I guess they would cite my thesis, and so maybe in the future it will be known as the Crawford equation. Who knows, to be honest? I don't know if it's actually that useful to people. So I'm kind of a little out of touch with the research community over the last few years. But that was certainly the main result of my thesis. So if anything potentially could be named after me, it might well be that. Okay. Sam has asked, do I have a partner? We've covered this so many times, Sam. I am currently single. I'll say it again, as I did in part 1. Okay, Scott has asked, e to the pi or pi to the e, which is better? Ooh, maybe pi to the e, because e to the pi is very similar to e to the I pi, which of course is equal to -1, Euler's identity. So maybe pi to the e is a bit more fun, because it kind of is less common, right? Because Euler's identity is quite well known. So pi to the e, I think. Nice question, Scott. Julian, as a student, how did I study? Was I organised from day one? I've always been pretty organised, actually, especially when it comes to work and study, Julian. So, I mean, I definitely think I found the first year of my undergrad the toughest, because it was such a big change from school maths, right? You have all this real analysis, epsilon delta stuff thrown at you. You no longer sort of have your hand held as much as you do at school. You know, you don't have like set working hours. You know, you have lectures, but it's up to you to organise your own time to then work on the problems. So I think I was quite good, to be honest. I've always been very good. I've mentioned before that whenever I got homework at school, I would come home and do it immediately, get it out of the way, and then I could go and enjoy myself, you know, go hang out with my friends, play video games, whatever. So I think I was, you know, I kind of have that like willpower, let's say, to be able to sort of get on with my work. So I definitely was good and organised. But yeah, first year was quite a steep learning curve. And then I kind of found my rhythm, found my routine, and then sort of settled in for the rest of the years. Okay, Maggie or Magi. Why did I leave Oxford my undergraduate and why did I go back after PhD? So I left after my undergrad because I wanted to try something new. I didn't really want to leave Oxford, to be honest, but I really wanted to do fluids. I spoke to lots of professors in the field and they said Cambridge is basically the best place in the world to do fluids. So I was like, right, aiming for that. And also I felt that going somewhere new, that change of scenery, meet new people, try new things, I think it just helps to make you a better person. So that was the main reason why I moved to Cambridge. And then to be honest, I moved back, I think, because I missed doing maths. As I mentioned when I had my job at the BBC, I missed just sitting down and doing maths problems. And so then I was thinking about how I can do that again and decided, oh, maybe I should teach at university. And it just so happened that there was a position available at St Hugh's College in Oxford. And so that was what I applied for and then moved back. But I was, of course, very happy to move back, having had such a good time in the first stint and enjoyed it so much. And I've now been back here for 4 years and I love it. I can quite happily see myself staying here long term, so we shall see. All right, number 146, slowly. Luke has asked, did I enjoy statistics much, especially its use in modern football? I teach first year stats and second year stats, so I definitely like statistics for sure. And I do really like how it's now used in football, definitely. I think the addition of things like expected goals has been a really nice sort of way that mathematical techniques have made it into like the mainstream. So there's a hell of a lot that goes into calculating the expected number of goals in a game. And the fact that it now like appears on Match of the Day as like a key stat is, I think, really cool to see that kind of mathematical work become part of like mainstream football sort of lingo, let's say. So yeah, I think it's awesome. I think it's really cool that all of this sort of work on data has made it into sports, possibly off the back of Moneyball, which, if you haven't seen that film, is amazing. All about using maths basically to pick really good baseball players and almost create a championship winning team. Great film. Okay, Abu Roop has asked, who is my inspiration for my lifestyle in general or teaching and way of life? Okay, teaching, I think I had some exceptional tutors when I was at St John's during my undergrad. So I was taught by sort of the big three, Charles Batty, Paul Todd, and David Sturzaker, all huge names in their respective fields. And I was fortunate enough to be taught by all three of them over my undergrad degree in my tutorials. And I like to think I take a lot of my teaching style from them, little bits from each of them to kind of create my own thing, but they definitely massively influence how I teach. But probably, I'd say probably Paul Todd in particular, because he taught me most of the applied stuff, which is now most of what I teach. Inspiration from my life? I don't think I have a specific inspiration. It's just about sort of being yourself, to be honest. So anyone who's just is themselves, I guess what I would say is an inspiration for like my general outlook on life and lifestyle. You know, I'm not trying to be a particular person. I'm just being me, doing what I enjoy, you know, projecting, representing me, and just, yeah. So I wouldn't say a specific person, more just kind of anyone who has that kind of like, I'm just going to be me and the world's going to have to just deal with it. I think is a great way to sort of live your life. Okay, Vlatka, any plans for first real vacation after pandemic? So, fingers crossed, I'm now double jabbed, had my second Pfizer earlier this week. So hopefully I'm going to be able to go on holiday in August with my brother and one of our friends. Where we're going to go yet, we don't know, because we're not sure what will be green list, amber list, who knows. So we've not planned where we're going, but we have a 2-week kind of gap, and we're all going to go on vacation somewhere nice and sunny with a beach, because obviously we have none of those that are good in England. So that's the plan, but we'll see. Watch this space. Okay, Irfan has asked, asking about disadvantage, having not taken further maths. So that's not necessarily, so you're at a little bit of a disadvantage having not done further maths, because you will need to know those techniques when you start your maths degree in Oxford. However, it's not a requirement to study maths here. So if you have to be doing maths A-level, and it's very, very helpful and highly recommended you do further maths, but you can still come and study in Oxford having just done maths. So that doesn't rule you out. In general, tips how you can get into Oxbridge. So obviously you've got to do well in the admissions test, which comes from lots and lots of practice. You've got to perform well at the interview. So again, I would recommend lots of practice, talking to others about maths, because that's what we do in the interview. So practice with your friends, with your family. It doesn't matter if they don't understand what you're talking about, but something you don't do much of at school is actually having a conversation with somebody else about maths. So I recommend trying to do that as much as you can to get used to talking about maths, because that's what the interview process will look like. Also, you know, we want people that are passionate about their subject. So any sort of extracurricular stuff you can do, whether that's watching videos on YouTube, going to talks, online lectures, reading books, all of these things that help expose you to more maths just generally makes you a better mathematician, and hopefully will increase your enthusiasm and passion for the subject, which is what and that will hopefully come across in the interview and the admissions process. All right, number 150, Scott, would I rather be an irrational number or an integer? Irrational number or an integer? Ooh, probably, that's a good question, you know. Maybe an irrational number, because I feel like an irrational number is more likely to sort of be unique in some sense. Sort of like almost like one of a kind. If you're some like ridiculously long decimal expansion, some transcendental number, then yeah, that's almost like a bit more unique. So I think I'm going to go with a rational number. But that's a nice question. Thank you, Scott. Right. Luis, is it true that for Zorn's lemma in infinite dimensions has a base? I have no idea what that question means, Luis. So I'm afraid I can't help you with that one. Right, Pedro, can I solve Rubik's Cubes? I've never tried, to be honest, Pedro. Apart from, you know, the odd, like, spending 30 seconds twisting one, you know, if I find it in someone's house or something. But I don't own one. I've never sat down and tried properly to solve one. But maybe I could. You know, maybe I can get Mike to teach me, right, as in Mike Boyd, because I know he did a lot of videos about learning the Rubik's Cube. So I've taught him maths. Maybe he can teach me the Rubik's Cube. Mike, if you're watching, teach me the Rubik's Cube. Or Pedro, do you want to teach me the Rubik's Cube? Mario, what's my favourite equation? Had this one, Mario. Navier-Stokes. Definitely Navier-Stokes. Scott, do you think I can make it to 250k subs? I hope so. If you all keep watching my videos and sharing them, then we can get there together. Etienne, do I find matrices are underrated, underestimated in the high school syllabus? Good question, Etienne. So I know that when I did my A-levels, matrices were only covered in Further Pure 3, which was an optional module in the A-level that I did. So what that meant was I didn't pick it because it was obviously much harder than, say, like decision maths, which I did instead. So I was making it easy for myself. But then when I came to university, in one of our first linear algebra lectures, the lecturer started writing like a matrix on the board, and I like turned to my friend next to me and was like, what is that? Because I know what a matrix was. So I think before they weren't emphasized enough, but I believe they are now on the core syllabus for further maths, I think. So my students tell me. So I think they're definitely like, you know, they're emphasized more than they used to be, which is a good thing. Because I'm guessing here, Etienne, you obviously have begun to realize how central they are to a lot of what we do in maths. And that's true for linear algebra in general. I think linear algebra isn't emphasized enough as just how key it is to so much of maths and physics and engineering and all kinds. Like eigenvalues, eigenvectors, matrices, just so much in there that appears in all these different places. So yeah, I think they should be emphasized more, yes, in short. Okay, Way Low has asked, did I take part in Olympiads in high school? No, I did not. Why has Cambridge produced more famous mathematicians and physicists than Oxford? Ooh, good question. I honestly don't know. I guess I've heard from people that Oxford is more known for the arts subjects and Cambridge for the sciences, which is maybe just a historical thing. I don't know how true this is. It's just something I've heard. So maybe that's why, because sort of historically, that's how things have worked out. As for exactly why, I honestly couldn't tell you, to be honest. I think across both universities, they're both such incredible places with such incredible minds and incredible students that, you know, I think it's quite hard to sort of judge them, you know, one against one another. That's why it's always one of those two that's like top of the rankings, right? Why do you use chalkboards and not whiteboards? I feel like maths is best done on a chalkboard. The main reason, though, I'll be honest, is because when you use a whiteboard, it reflects all the light. So it's really bad for filming. So that's the main reason I started filming on a chalkboard. But to be fair, even in my like office, when I'm teaching, I actually ask for a chalkboard to be installed because I prefer using chalk than I do whiteboards. There's just something about maths being done on a chalkboard that just feels right. But for filming purposes, it's definitely the reflection thing. Okay, Jose, explain Euler's identity. Okay, I actually talk about this in an upcoming number file video, Jose. So, you know, watch that. But Euler's identity, I briefly mentioned it before. You have Euler's formula, e to the I theta is equal to cos theta plus I sine theta. You plug in theta, and that follows from the rules around a circle and complex numbers and triangles. And then you plug in theta equals pi. So sine of pi is 0. Yes. Cos, I think about that one. Cos of pi is -1. So that tells you that e to the I pi equals -1, which gives you Euler's identity. The reason it's meant to be so beautiful is the fact that it contains these key constants. So the version I have tattooed has e to the I pi plus 1 equals 0. Because then you have like the 5 most important constants in maths, 0 and 1. So you've got your additive identity 0, multiplicative identity 1. You've got e and pi, like pi, this really important number in geometry, e, really important number in calculus, and then I as your complex numbers and square root of -1. So some would say they are the 5 most important, however you define most, constants in maths, and to have them in such a neat little equation is often why it's seen as being so awesome and so beautiful. Okay, Ray has asked, do I like stats? I've had this one before. I do like stats. I teach it to my first years and second years. Scott, a lot of these from Scott, who said, I proved the Riemann hypothesis, but this Google form is too small to contain the proof. Nice, Scott. Good nod to Fermat. Name, smiley face. Why do Oxford not do contextual offers like most other universities? That, to me, I don't know if that's true or not, but sounds like a university policy. which I have no idea about, if I'm being completely honest. All I know is when I'm doing my admissions, we look for the students we think, like the best students who we think will succeed and get the most out of studying here with us as tutors. And we absolutely take contextualized information, the context of your application, into account. So we have contextualized GCSE marks, which are calculated in a certain way to sort of show how well you've done in GCSEs relative to your background, and lots of other things. We have all of this information that we use when making our decisions. So all of that information about your background is definitely taken into account. As for the offers thing, I honestly don't know, because I'll be honest, I don't know exactly what a contextualized offer means. But if it's university policy, then I guess, I don't know, I can't really say anything or do anything about that, unfortunately. Praffle has said, transition from maths to fluid. I don't know what that means, Praffle, I'm afraid. Natsu, have I heard of the G exam in India? I've heard of it, mainly because everyone keeps commenting on my exam videos and saying I should do it. It's on the list. I don't know, we'll see. Maybe I'll attempt it, we shall see. I am planning to film some more exam videos over the coming months, over the summer, now that teaching's quietened down a little bit. So yeah, maybe I'll get to it, we shall see. How long will you be doing YouTube for? Well, if you all keep watching, I guess I'll do it forever. I don't really have an end game in mind, to be honest. As long as I'm enjoying it, I've mentioned this before, as long as I'm enjoying doing it, and I absolutely love doing it, and you all keep watching, obviously. There's no fun making something if people don't watch. As long as you all keep enjoying the content I create and I keep enjoying making it, then I'm going to keep doing YouTube. So, could be here forever, who knows. Julian has asked, how do you read a maths paper? Because you're saying that your prof told you that lots of them have mistakes. So when I used to read papers as a PhD student, I would kind of go through, I'd highlight things that I felt were important. I'd sometimes have to look up definitions, and I'd write those sort of in the margin and stuff if there was, it mentioned like finite element method or something, and I'd had to look up what that was when I started out. And then in terms of the calculations, I'd try as much as possible to work through them myself, because then it kind of helps you to understand what you're reading. And if there happens to be an error, which there could be, everyone's human, even though these things are checked, everybody's human, then maybe you will find that error. And that could lead you actually in a different direction, or could lead you to actually, develop your own research. If you find something that you think is wrong, then you can get other people to check that, and maybe it is, and then maybe you can sort of publish like the corrected version or something. So yeah, I definitely used to highlight things, look up definitions, and add those to like a page that I either attached to the paper or in the margin, and I would try and work through the calculations, because again, that helps to improve your understanding of what it is I'm reading. Okay, Mina says, several papers are published about mathematics and coronavirus. How about vaccines and math contribution in understanding the same? There's a load of stuff about that. I will be honest, it's not my research field, so I definitely will not in any way claim to be any form of expert or up to date with what's happening. But yeah, there's definitely lots of interesting things relating maths and the pandemic and vaccines and stuff, for sure. Okay, Long from Hong Kong has said, do I know how to play chess? I do know how to play. I haven't played since I was about 10. I played a little bit in primary school, and I mean a little bit. Not like competitively, just, every now and then would get out a chessboard and play against a friend or something. But I haven't played in a very long time. But sure, let's play online. Thank you for the offer. Okay, next question. Jose, favourite Pokemon and favourite Pokemon battle. So I have 3 Pokemon tattooed all on my leg, on my left leg. I've got Butterfree, I have Zapdos, and I've got Yveltal, who's a legendary from a slightly later generation. Butterfree and Zapdos, obviously from the original 150. Favorite Pokemon battle? Ooh, that's a good one. There's some that stick in my mind as like really tricky gym bosses or really tricky opponents in the games. I always remember, I can't remember which game it is, but there is I think it's a gym leader that has a slacking. So it's like, is it slack off evolves into Vigoroth, evolves into slacking. It's like a giant sloth-like Pokemon that's like lying on its side. And I remember that was insanely difficult to kill. in the gym battle. And also there's another either person, rival, or gym battle as someone who has a mill tank, like the cow, and has the move rollout, which is an absolute beast at that point in the game. And I remember that one was also really difficult. So maybe those. The ones that are tricky are the ones like when you finally do it, you're like, yes, did it. Like they're the ones that kind of you remember the most. So they're probably my favorites. Rami has said, how hard do you think it's for a foreign student to get into college like Oxford? I mean, we obviously accept international students. I teach lots of international students. Just in my first year, who've just finished at Teddy Hall, I have a student from France. I've got a couple of students from China and a student from India, as well as some from the UK as well. So we have lots of international students. And, you know, I've also taught students from Bulgaria, Romania, Italy, Spain, the US, all kinds, Poland, all kinds of different places. So it's different in the sense that your entry requirements will be based on your qualifications, but the university website will tell you what those are. So for whatever high school qualification you're doing, the university website will say what the standard entry or standard offer is, sort of once it's translated to your local qualifications. So as far as I'm aware, and you know, when we judge the admissions, we don't put any weighting or bias in any way on your nationality. You're just all judged under the same umbrella of we want you to be really good at maths. Scott again. I wonder if this is the same Scott or there's just a lot of people called Scott. Which hypothesis or conjecture would you like to see proven before you die? Navier-Stokes, to be honest. If someone could solve the $1 million Navier-Stokes millennium problem, that would be incredible. So I'm not sure you could call it a hypothesis or a conjecture, but I just think that would be awesome. Obviously, being in my field of fluids, I'd genuinely love to see that happen. All right, King Edward I. Good name. Hello, King. Your Majesty. Stats or mechanics? Probably mechanics. Probably mechanics. Yeah, being an applied mathematician at heart, you know, fluid mechanics, quantum mechanics, I teach both of those. Obviously, they're very different to perhaps the mechanics you do at school. But yeah, there's something about solving a physical real-world problem that's really nice. And especially when you get the result that makes sense with like your real-world experience, I think that's awesome. Okay. Number 173. Kasavaram has asked, what math stuff would I suggest an engineering undergrad to learn? Maybe linear algebra. So I touched on this earlier. Linear algebra is central to so much in so many areas that you don't realize. And it's probably not something you're taught, I would guess, in engineering, though I could be wrong. So yeah, I think linear algebra. In particular, I love how important linear algebra is to all of the stuff on machine learning and AI and stuff. I remember interviewing a couple of years ago some like very, very big names in artificial intelligence and sort of said to them, what would you advise mathematicians to learn who want to go into this field? And they were all just like linear algebra, linear algebra, linear algebra. It's all to do with that. So I'm going to say linear algebra. Edmund asked the question of a scalar product of 3 vectors. Is that possible? Scalar product. So you're talking about the dot product of 3 vectors. That wouldn't make sense. So when you take a dot product, you have a vector like A dotted with a vector B. And that gives you a scalar product because it outputs a scalar. So if you wanted to do a scalar product with 3 vectors, you couldn't do A dot B dot C because that just wouldn't make sense because you'd be dotting a scalar with a vector. But you can do what's called the triple scalar product where you do A vec B dotted with C. So you take the cross product or the vector product of A and B, and then you do which gives you a vector, and then you dot that with your 3rd vector, and that gives you a scalar answer. So there is a scalar triple product. That's a thing, definitely. Michael, recommendations for 6th formers to get an idea of what uni maths is like. I'd probably say that book I mentioned earlier, A Concise Introduction to Pure Mathematics by Martin Liebeck. I read that the summer before I started at uni. And I found it really helpful just to get you thinking a bit more like a university mathematician. Taylor, what were my career aspirations during university? Nice. I didn't know what I wanted to do, to be honest, Taylor. I tried everything. So the summer after my 2nd year, I went over to China and taught maths at a summer school. the summer of my third year, I worked as an actuary for an insurance company. And in the summer of my fourth year, I did a research project in UCLA over in Los Angeles. And I really enjoyed the teaching for sure, and I really enjoyed the research, but I wasn't so keen on like the actual job doing actuarial work. So I didn't know. I was trying all of these different things because I wasn't sure what I wanted to do. And I kind of decided to do a PhD because I felt like I didn't want to stop being a student. I enjoyed just doing maths and working on problems. And so that's kind of mainly why I went into the PhD, and because I enjoyed my experience of research as well that I'd had. And then I was also able to pick up teaching, which I knew I enjoyed after having done it for the summer. So my main advice is you don't need to know, but try lots of things. And then you begin to figure out what you do and don't like, and you can use that to sort of help guide you. Okay, Raymond, did I enjoy real analysis? It's really tough at first, that's for sure. I definitely remember struggling with it a lot during my first term at Oxford. But then when it all clicked, it was amazing. There's almost like, I wouldn't go so far as saying there's nothing more beautiful, but there's something that's just incredible about once real analysis makes sense. Once it all comes together and you finish like a full year of real analysis 1, 2, and 3, which we do here in Oxford, it just all seems so beautiful and logical and just amazing. But I definitely, so I did enjoy it by the end, but when I started, I definitely did not enjoy it because it was really hard. But it did eventually click, and then I loved it. Scott again, am I good at mental? Scott is loving these questions. Am I good at mental arithmetic? I guess I'm all right. I wouldn't say I have any special tricks, and I wouldn't claim to be a speed calculator or anything. But obviously, having done maths for so long, you begin to get used to multiplying things and working with numbers in your head. Though I should stress that obviously the more maths you study, the less you use numbers. It's all symbols, and I know the Greek alphabet accidentally as a result of studying maths for so long. Michael. Currently holds an office to do chemistry at Oxford. Awesome, congrats, Michael. Do you have any tips for Freshers Week and in general? Freshers Week, I am going to say do absolutely everything you can. So sign up for all the societies, go to every single event, and chat to everybody and anybody. Like, honestly, I can't recommend enough. Don't think that you just need to, find one person and stick with them, or, find your little group. Literally, try everything, meet everybody, because you have no idea when you're a fresher, like what you're actually into. So just try everything, figure everything out, and then eventually, once you try everything, you'll begin to see sort of like find your group of friends, find your communities within the university. So that would be my main bit of advice. Okay, David has said, when am I going to solve your sex equations analytically? I don't think I am, David. I'm not currently working on it. I hope someone does prove it though, like I said. You can solve it in some cases, right? So you can solve, in simplified cases like 2D flow and with no pressure gradient, stuff like that, you can solve Navier-Stokes analytically. But in terms of the million-dollar question, do solutions always exist? That's the thing that we don't know. Okay, Abinhav has said, can I please solve the G advanced... Well, another one. All right, I told you, it's on the list. We'll see. I'm not promising anything, but we'll see. James has asked, would I like to try the HKALE Pure Maths paper? Sure, James. Send it over to me. Contact form on my website, tomrocksmaths.com/contact. Ping me over the email and have a look, and maybe I'll do it this summer. But again, no promises. Robert has said Neil Gaiman is an English author. Yes, I've now realised this. I can't believe I said he was American. I don't know why I thought he was American. So yes, Neil Gaiman is English. Thank you everyone who pointed that one out. Scott, why do we use X and Y for axis labels, N for integers, etc.? Ooh, good question, Scott. I honestly don't know. I assume there's some historical context, probably a reason why they were first chosen, like back in the day. But I honestly, off the top of my head, do not know. But a nice question. Victor, what's your best advice to learn math for a 16-year-old? Practice. Expose yourself to as much maths as possible, whether that's YouTube videos, lectures, talks, reading books. Just find something you enjoy, whatever area of maths that is, and just play around with it. Be creative, do things yourself. Try and, if you see a proof, try and do it yourself. See if you can fill in the gaps. Just enjoy that playful process and lots of practice. My advice, Victor. Scott, what is my next tattoo? So I'm actually going to get tattooed at the end of this month. And I'm having a character from a video game tattooed on my back, which is from a very old PlayStation 1 game called Medieval. And it's the main lead character who's called Sir Daniel Fortescue. So I'm going to get him added to my other video game characters on my back. So that's my next tattoo. Garima has asked, how to make maths stronger and more stronger? Practice! Nicholas, which math topic do you think is advancing the fastest with research? Good question, Nicholas. I honestly don't know, but something that I am aware of, despite not being in the field, is maths biology. So mathematical biology is a relatively new field, and there seem to be just so many developments happening in that all the time. It's a very exciting field because it's sort of taking all of our techniques that we have in maths, differential equations, chaos theory, all kinds of cool stuff, and applying it to biological systems. So I think that is a really fast developing sort of topic research area. There's so much cool stuff you can do in there. So I think, to me, as an outsider, that seems to be developing very quickly. Saj would say, which of Newton's laws of motion is your favourite? It's got to be F equals ma. It's not very original, is it? But it's just amazing. And the fact that it then leads to Navier-Stokes, right? Your momentum equation, the big Navier-Stokes is just F equals ma. I love that. So it's got to be Newton's second law. How has COVID changed maths lectures? Scott again. I might have to start skipping Scott if he keeps sending questions. How has COVID changed maths lectures? Well, they're all online now, or the lectures, which hasn't affected me because I don't do lectures. I just do the tutorials. So I just teach in 2 students and me in a room for an hour every week going through problems. So I was doing those in person for the first half of the year, but then everything closed after Christmas. So then they went online. And then I was able to do a few revision classes last couple of months, again, back in person. So yeah, it's just kind of made the lectures go online because you can't have 200 people in a room and be socially distanced. Dino, how would I feel about schools using YouTube channels to build maths awareness and excitement? That would be amazing. That's exactly what we want. You know, like channels like you say here, mine, Number Files, 3-1 Brown, we are doing this because we love maths, because we want to share our passion. And if any of that excitement can be passed on to school kids, that would be incredible. So that's definitely want them to be shared with schools. Did I get sunburnt last weekend? I certainly burn easily, that's for sure. Whether I did last weekend, I can't remember off the top of my head. Do I watch PokerTubers from Andre? I've never heard of PokerTubers, Andre. But now that you've mentioned it, I will check it out. Thank you. Sounds like my kind of thing. Quasido, what genre of music do I like? Pop punk, metalcore, pop punk again. To be honest, currently I'm really into Machine Gun Kelly's new album is exceptional. I recently discovered a band called Hot Milk, who I'm really into. Also been listening a lot to Bring Me the Horizon over the last few years. I've been putting out some really good stuff. Very into that. And then like old school Blink-182, Sum 41, Fall Out Boy. Very much my jam. Very much my scene. Okay, Raphael. What are the most promising research directions in fluids? I would say turbulence. It's definitely like the hardest thing in fluids for sure. But I think the fact that we just don't really understand turbulence means that it's such a rich field. There's so much in there that you can like get stuck into as a mathematician. So I think turbulence is a really exciting research field, and there's things happening there almost on a daily basis. We discover new things about how turbulence works. All right, which football team do I support? Man United. Scott again. Salih has asked, are there ways to visualize abstract concepts like groups, manifolds, etc.? Definitely. So groups, as I said, I teach first year groups and group actions, and we spend a lot of time visualizing things through symmetry. So symmetry groups are very, very, are concrete examples that are relatively intuitive, that help to give you a feel for the abstract nature of groups. So the way the course is designed here is we start with looking at these concrete examples of symmetries, of tetrahedrons, of squares, of rectangles, and then take that and abstract it into this notion of a group. But it kind of starts, we motivate it through symmetry. So that would be my advice. If you're trying to visualize group theory, symmetry of different shapes is definitely a very good way to do that. All right, number 198, which means 60 to go. Whew. Kara, best books to learn maths like number theory for a person age 17. I honestly don't know, to be honest, Kara. Number theory is not really my thing. And as for something for 17-year-olds, that sounds quite tough. You could try Fermat's Last Theorem by Simon Singh, because of course that was a problem in number theory, which tells the story of how Andrew Wiles solved that problem. And that book is incredible. One of my favorite books, and I read that when I was 16. So should be good for a 17-year-old. Okay, Tom, which degrees and careers should I be looking at with chemistry, physics, maths, and further maths at A-level? Lots of mathematicians do that, to be honest, Tom. That's like the go-to. If you had to think of like the most standard 4 A-levels for mathematicians, it's usually maths, further maths, physics, chemistry. As I said, I just replaced physics with geography because I really enjoy geography. So yeah, I mean, degrees and careers, obviously chemistry, physics, maths. You could maybe do like natural sciences at Cambridge if you wanted to do a bit of everything. That kind of thing, maybe like materials science, engineering, other things that you don't learn at school that all those subjects would help you with. Careers-wise, pretty much anything, honestly. You know, all of those subjects are really well-respected subjects that teach you, you know, creative thinking, problem solving, all the important transferable skills you can take into any career. So you can kind of do what you want with those A-levels, Tom. Tommy has said, would I ever do a talk with A-level students? I do them all the time, Tommy. I did one yesterday. I'm doing one tomorrow, both of it with A-level students. So yeah, I do talks to A-level students all the time. So just keep your eyes peeled on the events page on my website because lots of them are online and you can join. Okay, Liam, do I follow any sports? And if so, who do I support? Football is Man United. I used to follow, not so much anymore, used to follow the NFL, American football, and I'm a Baltimore Ravens fan because my great aunt lives in Maryland, so that was why I picked the Ravens. Basketball, I'm Golden State and my team in basketball because I went to see them. So they were good for a very good, I went to see them when they were good, so it sounds like I'm a Glory supporter, I guess. But they were the first basketball team I went to see live when I was in the US, and it was amazing. So they had to be my team, but they're not so great now, so maybe I'm no longer a Glory supporter. Other sports, oh, my hometown team, Rugby League, Warrington Wolves. So Warrington, where I'm from, have a very good rugby league team called Warrington Wolves, so obviously have to support the hometown team when it comes to that. Abdul has asked, struggling with calculus, any advice or resources? I really like the 3 Blue 1 Brown series, The Essence of Calculus. That's amazing for teaching you the basics, you know, in the usual Grant style of everything be very visual. If you're looking for specific topics, I'm doing my Oxford Calculus series, which obviously is aimed at university level, as you mentioned, and I'm covering specific things. So I've got like partial differentiation, critical points, PDEs, integrating factors. So if you're looking for a specific topic, then I've got quite a few videos, but I think the 3 Blue 1 Brown series is excellent. Stoiker has said, cars, motorcycles, or bicycles? Well, I only own a bike of those three, because in Oxford you don't really drive. It's a small city. You get everywhere on a bicycle. So I guess a bike. That would be nice to have a car. I'd love to have a Corvette. If I could pick any car, like that was reasonably affordable, it would be a Chevrolet Corvette. I've always liked those. In probably bright yellow or bright red. Probably bright yellow. Bright yellow Corvette. I was going to pick a car. Rene, how many languages do I speak? Unfortunately, just English. I did French for 5 years, from the age of 11 to 16, and I did German for 2 years. But I've almost certainly forgotten the vast majority of both of those, because I just haven't practiced since I finished it at school, which is entirely my own fault. I used to really enjoy French as well, because every summer with my family, we'd go on holiday to France. And, you know, they'd be like, oh, Tom, you can just speak and deal with things. And so I had many broken conversations with lots of French people, which I think really helped me to improve as well, which was good. but I haven't spoken it for so long that I would not claim to be able to speak anything at the moment except English, unfortunately. But I'd love to learn another language. It's been on my list for ages. It's just finding the time. All right, number 205. We're getting there. Alan has asked, is there any theorem or result that I would like to prove? I mean, I'd love to prove any of the big problems, right? Would be amazing. Just to have your name sort of like associated with one of these long-standing mathematical problems would just be insane. So I guess Navier-Stokes, as I said, I'm not currently working on anything, but it would be incredible if, I happen to be the person that finally did the Navier-Stokes. And plus the $1 million would be pretty nice. So yeah, I think Navier-Stokes, to be honest, if I could have anything with my name attached, it'd be that. Tim, am I into any kind of physics? Have I ever visited or wanted to visit CERN? I would love to visit CERN, Tim. I hope you're inviting me. If you're inviting me, Tim, let me know. I will absolutely love to go to CERN. I can film a video there, it'd be great. Am I into physics? Definitely. I've mentioned a few times I teach quantum theory, relativity. I taught a course this year for the first time on theoretical physics. So yes, absolutely. I really enjoy it a lot. I would love to visit CERN. Kasun, how someone who is not so good in math improve? Practice. Again, there's no shortcuts. Kasun, you've got to practice, and if something doesn't make sense to you the first time you read about it or are taught it, find somebody else explaining it, because you'll eventually stumble across a particular method or a particular teacher that explains it in ways that make sense to you, and that's very personal. And you do have to put a bit of work in to try lots of different approaches, but eventually you will find the way that it makes sense to you. And obviously then you have to practice a lot. Lexi, will you marry me? I'd have to meet you first, Lexi. I don't think based on a Google form submission I could accept your proposal, but I appreciate it. Quasido again. Okay. Talking about good resources for understanding category theory. Ooh, I've never studied category theory, so I'm definitely not the right person to ask about this. I do, however, remember going to a talk from an amazing maths communicator called Eugenia Cheng. She's also written some books, which I believe are awesome. I haven't read them, but everyone tells me they're really great. And her talk was fantastic, and she talked about category theory, and I remember it being amazing, the way she explained it. So if she's got anything based around category theory, that would be my recommendation. Arjun, what are the criteria or method to find the inverse of a matrix? If this is a throwback to the Maths A-level video, you can do it that way, which took me, 10 minutes, 15 minutes, using elementary row operations, and then you can invert the matrix. So that's one way to do it. You can also use the adjoint matrix is another method, or the matrix of cofactors. If it's a 2 by 2, there's just a formula where you swap two of them and change the signs and divide by the determinant. There's formulas and techniques for these things, but the general method for any size matrix, I would say, is elementary row operations. Julian, has teaching made me a better mathematician? 100%, Julian. There's a reason that there's the saying, you don't understand something until you can teach it. It's so, so true. The more I teach a particular topic, the more I understand it. And I absolutely love it as well, because I feel like sometimes I'm learning as I'm teaching the topic, which is not, I don't think is a bad thing, right? There's always more to learn, right? Even for a tutor, someone teaching it. So yes, teaching is so, so important and really good at improving your knowledge and your understanding of a topic. Ilyas, improve my study efficiency without losing interest and concentration. Again, you're going to have to practice, Ilyas. If you're struggling with concentration, do things in short blocks. So maybe do 40, 45 minutes of work and then have a 10-minute break. I like to, usually I'll split my day up into 2-hour sections where I'm doing this for 2 hours and then I have half an hour to just chill, this for 2 hours, half an hour to chill. I kind of do it like that. I try to split my days up with exercise because I find that helps me to wake up and sort of get my energy back, go out for a run or go to the gym, for example. So trying to split things up into chunks is a really good way. It's impossible to sit and just be 5 hours of solid work. That's not good. You need to add in those little breaks, whether it's just walking, I don't know, to your cupboard to get a drink or something, or a 5-minute walk outside or whatever. Try and split things up into manageable chunks. Sam, how many hours did I study per day when I was doing A-levels? Hard to know, to be honest, Sam. I would always do all of the questions that were in the book that was set for homework, plus probably some extra ones just because I was enjoying it and I knew that practicing was the way to improve. When I was revising my exams, I would do like a ridiculous number of past exams, maybe like 20 past papers for every exam I did, especially in maths, because I found them fun, to be honest, and I felt it was a really good way to practice. But as for an exact number of hours, I honestly couldn't tell you. But when it came to my exam time and revision, I was definitely, solid, like 8 to 10 hours a day, like studying and revising ahead of my exams for sure. Victor has asked, does doing 4 A-levels lower the minimum grades needed to get in? I don't believe it does, Victor. I believe we asked for 2 A stars and an A. So you need an A star in maths, an A star in further maths if you're taking it, and another subject with an A. If you're doing 4, it doesn't make a difference. You still need those 2 A stars and an A. Vasim has asked how the velocity of a fluid depends on the width of a pipe. Well, it depends on the type of flow. To be honest, that's quite a technical thing. I'm trying to remember off the top of my head. There's Poissier, I can't say that word, flow or pipe flow where you have a quadratic velocity profile. So it goes to 0 along the walls, and then in the middle you have your peak velocity in the center, and then it decreases to 0 as you go to both walls. As for exactly how it depends on the width of the pipe, I'd have to sort of solve the equations and know more about the problem, to be honest. Nishfish, does having 3 A-levels affect transferring into Oxford compared to 4? As I've just said, I believe, as far as I'm aware, the standard offer is 2 A stars and an A, at least for maths in Oxford. So it doesn't matter if you do 3 or 4. I guess by doing 4, you've got more chance in case one of them happens to be a B or something. Then you kind of can save it with another. But if doing 4 means you can't put as much time into the others, then it's up to you to decide that, to be honest. I ended up doing 4 just because I enjoyed them all and I didn't really want to drop one. To be completely honest, but yeah, 3 is like the standard offer. Long from Hong Kong again. What do you do when I feel frustrated or self-doubting in my career? So this happens to everybody, and it's definitely happened to me sometimes, and I think you just have to kind of like take stock of what you have achieved and focus on the positives. I know this is easier said than done, but if you're ever reaching that moment where you're just frustrated or annoyed, sort of take a step back, take some time away from your work, do something else that you enjoy. So for me, that would be going running, doing some exercise, playing football, and focus on that. And then you come back to your work a little bit more refreshed. When you perhaps start to doubt yourself, I think sort of trying to take stock of what you have achieved. So, if you're doing an undergraduate degree and you're starting to doubt this, then think, well, no, actually, I recently did this in my test. I, did well at school, and just remind yourself of like the positive and the good things you've done to get to where you are. I think is very good at trying to alleviate some of that self-doubt, but it happens to all of us. I think it's a very common thing. So it's certainly nothing to be ashamed of by any stretch. It happens to everybody, myself included. But I just try to focus on the positives and think about all the things you have achieved rather than what you've maybe not or something like that. Right, last 40. This is number 280. Costas. What is my full-time job? Official title, I am an early career fellow in teaching and outreach at St Edmund Hall, one of the Oxford colleges. So my job is I teach undergraduate students in first year and second year maths. I teach the visiting students who come from all over the world to come and study for a term or sometimes a year at St Edmund Hall. And I do the outreach component. I run Tom Knox Maths, creating YouTube videos, everything on my website. And I do lots of talks in schools, online, events, conferences, the whole thing. So that is my job. My job is literally to do outreach work, try and get people excited and engaging with maths, and to teach maths to undergraduate students. Ishara has said, trying about getting better results for advanced level maths paper. Again, it's just practice, Ishara. It's practice, and it's, if you don't understand something, find somebody else explaining it in a different way, through videos, through textbooks. They are my key 2 things to improving at maths. Salih has asked, do you use any kind of electronic device for writing in order to avoid paper consumption? Interesting. When I'm doing maths, I use pen and paper because I prefer to do it that way, for being completely honest. It's just how I've always done maths personally, and I find it better than writing on like a tablet. But if I'm just taking notes or like writing things up, then I will just use my computer and type like most people. So I do still use paper for doing actual maths because I just find that sort of easier. It feels more natural to me. Lucas, favorite YouTube channels? I mean, Numberphile. I've been watching Numberphile since I was a student and still do, and it's amazing. Aside from Numberphile, would be my go-to YouTube channels. I mean, all the other maths ones, Stand Up Maths is amazing, Feeble One Brown, it's obviously really good. There's actually, I can give you a music one. There's this guy recently discovered called Alex Melton, who has a channel where he's recently been doing pop punk songs, so the songs that I enjoy, my genre of music, but he's been singing them in a country music style, and it's incredible. It's not something I ever thought I would particularly enjoy, but I stumbled across it one day and I was addicted. I ended up watching like 30 of these videos, and it was really, really good fun. So that would be my sort of rogue shout of a YouTube channel I'm currently very into. Ryan, what's my favourite tattoo? This changes all the time, Ryan, to be honest. I really like my Pokeballs, right, the real one and then the pixelated one. I love my Pokeball tattoos. We've got a new one there, which some of you may recognise is one of the runes from Witcher, the video game and the Netflix series. So that's the mind control one, so don't stare at it too long. So my favourite one just changed. I've got a Crash Bandicoot on my side of my back ribs a little bit, which I love. I've got a Cartman tattoo from South Park when he's dressed as the Coon, his superhero alter ego. I really like that one. So there's lots. It changes all the time. It really does. But there's some of my favourites at the moment. Lorenzo, what's the meaning of the Pokeball? I love Pokemon, Lorenzo, and I couldn't decide whether to get pixelated or realistic, so we did both. that's the meaning behind it, I guess. Scarlett's asked my favourite tattoo, so we just had that one, but good question. Mike, grade 10 student, any tips on how to study better and more effectively? Again, lots of practice, find alternative methods, and take breaks for more effective study. So I've talked a lot about those kinds of things. Deep has said, why is 0 over 0 not defined? Because it can be equal to anything. So depending on how you take that limit, it can have any value. So this is why L'Hopital's rule exists, because it tells you how to properly compute 0 divided by 0 through a limiting process. So you can actually construct it to be equal to anything depending on how you take the limit. So that's why it's not defined, because it can be anything. Scott, glass half empty or glass half full? Definitely half full, Scott. Tris, I'm sure we could guess some of what were your favourite modules through my time as an undergrad. So fluids, some of you could guess. I really liked multivariable calculus. I really enjoyed PDEs. I really enjoyed quantum theory. Math biology that I studied was amazing. My absolute favourite was a 4th year course called Mathematical Geoscience, which was incredible. Because we were studying the formation of rivers, we were looking at glaciers, we were looking at the climate, just like mainly focused around fluids, though not all fluids, but just it was so applied. It was like modelling of like the natural environment and the natural world, and I thought that was amazing. So yeah, Mathematical Geoscience is a really cool one. Junaid Ahmed has said, with who is your dream collaboration? Ooh, I would love to do a video with Travis Barker, who's definitely not going to be watching this. But if you are, Travis, so Blink-182, favourite band ever, love them. And I love what Travis is doing recently with his like reinvention of pop punk. So I'm just loving that, and I think Travis just seems like such a cool dude, all of his amazing tattoos and everything else. I don't know what collab we would do, right? Something involving like the maths of drums or something, or music. But yeah, that would be my absolute dream collab, definitely, Travis Barker. Jonathan, what is your best advice for new university teachers in mathematics? Okay, top tip, because I found this insanely helpful when I started out teaching at university, is the problems that my students had to do that I was then going to teach them on and run my tutorial on. Even though I, in most cases, have access to the solutions, I would sit down and do the problems myself. Now, hopefully I'm going to do them a lot faster than the students, being more experienced. But by doing that, you actually see what are the hard parts in the problem. So by doing it yourself, the points where you get stuck are exactly the bits where the students will get stuck, right? So you already spot those before you even see your students' work. So I found that really, really helpful because I could identify the tricky bits, identify where the students would struggle, and that then allowed me to figure out how I would do it so that I then was like prepared to talk through that with the students in the class. So that would be my top tip. Do the problems yourself. Regardless of whether you have the solutions, do them yourself. Shenpu has said, advice I give to a high school student who wants to study maths. Main advice would be to explore the subject, play around with it, find a topic you really enjoy, and just like try and, do a proof for yourself, or like even if you're just filling in the gaps of someone else's proof. Play around with maths. It's very fun and very creative, and a lot of people don't realize this, especially in school. So I would recommend doing that, and I think that will only help to increase your excitement and your passion for the subject. Okay, down to the last 25 or so. Okay, Rachel, what's my favorite song? What's My Age Again by Blink-182. I have it tattooed on my shoulder, the words What's My Age Again. It was one of my first tattoos, third or fourth tattoo that I got. And I just love it. I think the song's amazing. It's so catchy. I love what it's about never growing up, which is, hey, look at me. Don't ever plan to grow up. And I love the video. Obviously, the fact they just run around the streets of LA naked, being the naked mathematician, it's very close to my heart. So yeah, favorite song, What's My Age Again, Blink-182. Albert has asked about Maclaurin series. And then he's asked the theoretical reason velocity depends on the area of a pipe. The Maclaurin series one's a bit technical, Albert, but the fluid and the cross-sectional area of the pipe. So what's happening there is, if you just think on a very basic level, speed is distance over time. So your distance in like the flow through a pipe has to come from the cross-sectional area, right? That's representing like the flux. If you're thinking about how much fluid passes through a certain cross-section or a certain point in the pipe, clearly as you make the pipe shorter or bigger, that's obviously going to affect the pressure, and that will affect how fast the fluid moves. So I just tend to think of it in that context. If you think of it in terms of like a flux and a pressure gradient, then I find it's very intuitive, therefore, that the cross-sectional area will actually affect the velocity. All right, Cameron, what A-levels did I take? Maths, further maths, chemistry, geography, and I did an AS level in critical thinking, which was really fun. Taught me lots of skills about logical thinking and arguments. Xander, will I make a video about rewriting a high school final maths paper? So I'm guessing here you maybe mean a GCSE video, which if you do, I have a secret plan of doing a GCSE maths video. I can't reveal what the secret plan is, but I will be doing a GCSE maths exam this summer. But you'll find out more. That one will be announced. Losel, what was your childhood like? It was really good, to be honest, Losel. I played a lot of football. I hung out with my friends. Again, playing football, played a lot of video games. Spent a lot of time playing Metal Gear Solid and Assassin's Creed, the original Assassin's Creed. When I was growing up, obviously spent a lot of time playing Pokemon, collecting Pokemon cards. No, I had a very fun childhood, to be honest. My parents were very supportive, and they encouraged me to work hard at school and everything else. I think I was quite fortunate. I've had this discussion with a few people recently. I feel like I was quite fortunate in the era I grew up in because I still went out and played out with my friends. We would build dens and ride our bikes and make jumps and stuff like that. But at the same time, the PlayStation 1 came out when I was a kid. So we also kind of got to experience video games properly. So I feel like I had the best of both. We still used to all go out and make dens and do all that cool kid stuff, and at the same time play video games. So I really enjoyed sort of being able to do both of those things when I was growing up. Bronte, please explain the cylindrical polar frame of reference. All right, so cylindrical polar coordinates is basically you have three-dimensional coordinate system, and you just imagine having the whole of space as a giant cylinder. So you've got a height, which is z, and then to determine how far in your x or y directions you're going, instead of going in x or y, you just define it by how far you are around a circle. So if you're very close to the origin, then you're going to have a small value of your radius, but if you're far away, then your radius is big. And then once you know your radius, you know your distance from the origin, you then can form a circle of that radius, and then to determine where you are on that circle, you have to give the angle, which is your theta. So in cylindrical polars, what you're doing is you're taking your xy plane and redefining your coordinate xy in terms of distance from the origin and angle. So that's r and theta. And then z is just that 3D extension into the vertical. Felicity, is there any country I want to visit after COVID? That's a very good question, Felicity. Where do I really want to go? Oh, I really want to go to the Galapagos Islands in Ecuador, actually. So I've been to South America quite a few times. I'm very fortunate. I had a lot of trips to South America, and I love the place. Everywhere I visited has just been amazing. And yeah, I'd really, really like to visit the Galapagos Islands because obviously the wildlife there would just be so incredible to see. So I think that's going to be, I don't know whether I'll get there, but that would be somewhere I'd love to go to. Mark has asked how to teach math in an engineering class. I guess possibly the main difference there is you're going to be focusing on the applications. So I would try to stress that to the students. Because if you're an engineering student, you're clearly very much focused on applications of the maths you're studying and real world problems. So I personally would try to teach engineers through their applications. So start with, this is the problem we want to solve, this is the maths we need to solve it, now I can teach you the maths. Because you've already got their attention by getting them interested in the problem that it's going to apply to. I think that's a better way around of doing it than trying to be like, here's some maths, and then at the end saying, oh, and this is why we did it. I would always start with that motivation when teaching engineering or physics students. With mathematicians, you can just start with, here's some amazing maths. But with the more applied topics and subjects, I think it's really good to start with the motivation first. Okay, number 240. We're nearly there. We're nearly there, guys. Whew. All right, number 240. From Silver Moon, what colour will I colour my hair next time? So I don't normally, if at all, dye my hair, Silver Moon. This is the second time ever that I have dyed my hair. So I guess I don't plan to dye it a different colour next time, right? And I didn't even dye this was just bleached. We just bleached my hair and this is what happened. And I'm blaming COVID for this because I got, I'm claiming I went mad in lockdown and this is what happened. So yeah, I don't have any plans, to be honest. I'm really enjoying the white kind of blonde that I've got going on. I hope you all like it. I'm a big fan of how it's turned out. But yeah, no other plans, to be honest. Have I ever done a step paper, the Cambridge entrance test? Would I consider sitting one like I did the GCSE A-level for maths? It's on my list, Alf. It's on my list as a potential exam. Again, I'm not making any promises. We'll see. I have done one. I used to mark the step paper when I was a PhD student. And before I would mark it, just like I mentioned before, when I teach, I do all the questions myself. So before I mark the exam, I also sat down and did all the questions myself. So I've definitely done one. I didn't do it in person as a student because I did the MAT because I applied to Oxford. But I have done papers in the past when I was doing the marking. And we'll see, maybe I will do it in my exam series. Bronte's back. For two connected particles, one spinning on a horizontal plane and one vertical. I think this is maybe relevant to the cylindrical one. So I've already done that one, Bronte. PV, how did I know I was good enough to pursue a career in maths? Passion can't be enough on its own, and doing well in exams is very different to being a working mathematician. True. So I guess how did I know? I was always in the top set for maths. I did very well in my exams at school because I enjoyed it, to be honest. I enjoyed it, and it was just a hobby. I would just practice and solve maths problems because I enjoyed it. And obviously that translated into becoming very technically proficient with maths and doing well in my exams. So I guess that's sort of one way of knowing you're good in some sense. And then when that continued through university, and continued to work hard, was doing well in my exams, I guess that sort of began to make me realize perhaps I could have a career in this. But yeah, to be honest, I see what you're saying about passion isn't enough, but because I enjoy it, because I'm so passionate about it, means that I don't mind putting the time in order to be good at it. So like the two kind of come hand in hand, I think. So, and also I've talked about this before, that I think maths just makes sense to me. My brain thinks in numbers, it thinks in patterns. So maths just seems like the perfect fit for me. And again, you know, by all measures of doing exams, coursework, etc., I seem to do well. So I think that just kind of perhaps sort of, you know, made me think, oh, maybe this is the correct career. This is what I should be doing. And so I just kept doing it. You know, the fact, like for my PhD, the fact that I was amazed that I was going to get paid as a PhD student, not much, but you get a stipend to live off to just do maths, which for me was incredible. And I was like, how would I not want to do this? This is like the dream. Okay, Leo, if my grades are low, is it a good idea to pursue a first degree in maths? I mean, that's up to you, Leo, right? If you want to do something you enjoy, then and that happens to be maths, then I'd say do it. If it's what you enjoy and it's what you want to do. But, you know, I'm aware that you have to be realistic. If you're not doing very well in it, then obviously perhaps maybe it isn't for you, or maybe you need to work harder, or maybe you need to find a different way of studying. So I think it's an individual sort of, you know, it's your individual position as to whether or not you can do something despite not being good at it. Because I'm aware that ultimately, you know, you want to do a degree to be able to get a good job and to be able to, you know, live a good life, etc. But I think there's a lot of value in doing something that you enjoy, though, for sure. Long, what's my take on geometric algebra? I'll be honest, I've never really studied that much geometric algebra. You know, algebraic geometry, I've never taken that course. It's a third-year course here in Oxford. I teach geometry and I teach algebra. I enjoy them both. So maybe I would enjoy algebraic geometry, but I've never personally studied it long, so I couldn't say. Sam, what's my favourite flavour of ice cream? Great question. Ooh. Okay, if we're going like plain, chocolate. If we're going slightly fancier but traditional, really like Rocky Road. If we're going for like specific branded ice cream, like basically anything from Ben & Jerry's is amazing. I think maybe fish food from Ben & Jerry's. That one is great. The little chocolate fish and the caramel and it's just, yeah, probably that one. Let's go with fish food from Ben & Jerry's. Ishan, can I do a G paper, JEE paper? It's on the list. Not making any promises, we'll see. Ali has said he's done GCSE further maths. Does that help in the transition to AS and A-level? I would guess so, Ali. Further maths GCSE didn't exist when I was at school, and I will be honest, I don't know that much about it, but you know, I imagine it exists now precisely to help with that transition. So yes, you know, if you're doing harder maths and you do it maths GCSE, that's definitely going to help when it comes to your A-levels. Mew, good name. One tip for maths and stats: practice. You know, there's no shortcuts here, guys. You'll keep asking this. You just got to practice. I love maths. As soon as my GCSEs, want a career which includes it, but not a pure maths one. Any ideas? I mean, I wouldn't worry too much, Cameron, if you only just finished your GCSEs. And also, you're going to do so much different maths if you're doing it at A-level. So I don't think you know yourself yet exactly what maths is until you've done A-level, or probably until you've done university. You don't really know what maths is, to be honest. My whole idea of what maths was changed so much doing it at degree level. Any idea for careers? I mean, anything in finance is going to be pretty well paid. It is a solid job to go into, and maths is super helpful for that. You know, actuarial science, working in insurance is very, very well paid. You have to do more exams though, and I personally didn't like it. Teaching, I love teaching, so gonna have to say that's great. I mean, yeah, like you really can go into anything, so I wouldn't worry at all, especially if you've only just done GCSEs. You've got a long time to figure that out. Jonas, I get to be in charge of the world's education. Amazing. I wish. What would you... Well, do I wish that? It's a lot of responsibility, Jonas. What would I add or remove from the curriculum? Okay, the main thing I would change about the maths curriculum is I think we should focus more on the problem-solving aspect of it. So what I mean by that is... And the story behind the maths you're doing. So, for example, let's take trigonometry. Like, don't present trigonometry as, here's some rules about triangles. Or Pythagoras' theorem, here's this thing about a triangle. Like, that in itself is really cool. But if you're not necessarily into maths as a student, you're like, why do I care about this? When am I ever going to use this? So I think you should be teaching this in the context of like where it came from. So trigonometry, Pythagoras, etc. Super helpful for like architects trying to build buildings in ancient times. If you're an explorer, you can use trigonometry to estimate the height of, you know, the hill or the mountain in front of you. Like, there's so many cool ways that these things are used. So I think the main modification I would make is to teach those topics through the art of problem solving. So, you know, present a problem of like, right, you're an ancient explorer, you've discovered a mountain in the distance, and you need to estimate its height based on where you're currently stood. How can you do that? Turns out, you use some trigonometry. So I just think that, to me, is just like creating the story around what you're learning and putting it into some context is the main modification I would make when it comes to maths education. Okay, 252 says, do an example of Math 55. So I think I've spoken to you before, Rijo. So this is the supposedly the hardest maths course in the world at Harvard. I've actually got a video covering this with Math with Bad Drawings with Ben, where we talk about Feynman's integral technique. So there is an example in there. So check that one out. Einon has said, do we need to have higher IQ to understand maths? And you like my blonde hair. Thank you, Einon. So I've been asked about IQ and IQ tests and things before. So I've never taken one. I've never taken an IQ test. I guess I've just never been asked to. But I've not really had much of an interest because I think they test a certain, like all exams, like it's a certain way of thinking, it's certain techniques, you can practice certain things to like improve at them. So, and to be honest, I don't feel like having a number associated with your intelligence is actually a good thing, right? You know, we all have different talents, we all have different skills, we all work in different ways. And I think we should like celebrate that more, right? Like, you know, clearly I enjoy teaching, I enjoy fluid mechanics, I enjoy communicating maths. So, you know, that's just what I do. Like, why does that need to be like, you know, why do you need to give that a numerical value, or why do you need to rank things? I think sometimes we can get a bit too focused on that. So yeah, I don't think necessarily, you know, your IQ according to some random test relates to your ability in maths. It's just it's measuring a different thing from my perspective. Okay, Rijo's back with an example from Math 55. Oliver, how naive is it to study math with the dream to become a researcher? I mean, it's not naive at all, Oliver. I mean, it's hard, and it depends a lot on the field you want to go into. So in general in the UK, the research picture, it's mixed depending on the university or different things, but I believe that pure maths research is much more competitive because the funding is much more restricted. Because generally pure maths funding kind of has to come from research councils, governments, things like that. Whereas in the applied maths sphere, you can get funding from industry. So there were lots of people in Cambridge in my research group who were funded through external companies, you know, like Dyson, BP, Schlumberger. They all funded, Rolls-Royce all funded programs for PhD students in Cambridge. So because of that, there's like more positions available, often anyway, in applied maths research. So that's just something to sort of bear in mind. It doesn't mean you have to do that, but I would say talk to people in the field and just be aware that it is very competitive and, you know, it can be very difficult. Lots of people find it sort of overwhelming, but, you know, it's certainly, I think it's a great dream to have, and if that's what you want to do, I say go for it, definitely, but sort of be realistic at the same time. Kevin, how to get into Oxford or Cambridge for maths? Be very, very good. You know, practice a lot, do well on your exams, make sure you do well on your admissions tests, which comes from practicing lots of them, learn how to answer those style of questions, and be passionate about your subject, right? So watch videos, read books, really demonstrate that you love what you do. Ishan, algebra versus calculus. Calculus all day, Ishan. Your pick and why. So definitely calculus, because calculus to me is the main tool we use to model the world around us. And I love mathematical modeling. It's like my favorite thing in all of maths is taking all these techniques and methods and applying them to real world problems and solving them. So calculus to me is exactly how we do that. Anything to do with motion, movement, rates of change is all calculus. So I'd have to say calculus, but nice question. And final one, 258. We got there. I can't believe I did all of this. 258 from Leonardo. Is further maths A-level only for naturally gifted or does hard work? You can categorically do it with hard work, Leonardo. you know, like with most things, if you are gifted in maths, you're obviously going to probably not have to work as hard. But there is no substitute for hard work. Putting in the hours, putting in the time, practicing, you know, making sure you understand everything properly is key to success in any area of maths, in any mathematical qualification or exam. So definitely, yeah, if you enjoy it and you're willing to put in the hard work, definitely do it, and I'm sure you'll smash it. Right, so that's it. That was question 258. We've done it. I managed to do all 150 questions to complete the entire submission from everybody from the original live stream. So again, thank you as always for watching. I don't know how much of this you watched. If you're still here, well done on still being here. I love that commitment. Of course, I'm guessing if you're watching this, you're probably already subscribed. But if you're not, you know, if you've got this far, you might as well subscribe to the channel for more maths videos every week. And again, just a massive, heartfelt, genuine thank you to all of you for supporting what I do, for supporting maths, for supporting just general online creators on YouTube. I think it's just amazing, the communities that we build. And I love these interactions and I love being able to answer your questions. So again, just thank you so much, really from the bottom of my heart. And yeah, hopefully we'll be back for the next one at 100K. Exciting. Right, take care.